We've considered z-scores as a measure of your positioning in a data set. So if your z-score is positive, you're above the mean. Z-score is negative, you're below the mean. If your z-score is 0, you are at the mean. But there's another measure of position that's very important for us, and that's, well, there's two of them, but they come together, percentiles and quartiles. All right, percentiles are the 99 values that divide an ordered data set into 100 equal parts. Now just think about that for a second. If you have a line and you want to divide it into 100 parts, you need 99 little dividing sectors, right? Little dividing lines in order to make those 100 parts show up. Each of those little lines is called a percentile. Now the symbol for them is P sub k, but k is the percentage of the observations that are less than or equal to that value. So for example, the first percentile is P sub 1, the second percentile is P sub 2, the third percentile is P sub 3, and so on. Sub meaning it's below, the little numbers below the capital P. Now, we have three very important percentiles that matter more than the rest of them, believe it or not. We have the median, the first quartile, and the third quartile. Now the median we've already run into. It's the same median we saw in section 3.1, and it is the 50th percentile. So the symbol for that would be P sub 50, right? And then you could also think of it as the second quartile, because the quartiles are going to divide the data set into 4 equal quarters. The first quartile separates the bottom 25% from the rest. The second quartile, the median, separates the bottom 50% from the rest. And then the third quartile separates the bottom 75% from the rest. And between those three numbers, you've divided up your data set into 4 equal parts. Notice the symbols here. So Q2 for second quartile, Q1 for first quartile, excuse me, and Q3 for the third quartile. And if you wanted to think of them as percentiles, it'd be P25 for this one and P75 for this bottom one. All right, and we're going to look more at a picture of how these three numbers in particular divvy up a data set, but that's in section 3.5. All right, now we need to learn how to find these values, in particular these three, because the calculator finds those three values. They're more important, if you will, than the percentiles, although there are more percentiles than there are quartiles, obviously. All right, so how do we find all these numbers? The minimum, the maximum, the median, and the quartiles. Those 5 numbers together, because there's 2 quartiles, they count as the 5-number summary. Very, very important for section 3.5. So this is going to come back to us. All right, so how do we do it? Well, you go to Stat, you go to Edit, and you type in your data set. So I type 54, 60, and so on. Oh, and I cleared out my old data, first of all. So you go up, I'm not going to do it because I already typed this in, but you go up, clear, enter, and clear out the old, and then type in this new. All right, so then I have those data numbers right there. So I'm going to press Stat, go to Calculate, pick number 1. I want L1 for my list because that's where my data are, but I want frequency list to be blank. So I press clear if I had L2 in there. Clear it out, you want nothing there. You only use frequency list when you have a frequency distribution or a relative frequency distribution or a weighted mean, things that we had in section 3.3. Remember when we were looking at the old faithful geyser? That's a frequency distribution. So you would use L2 to get your frequencies in the calculator. But we don't need that now because we just have a giant data set of raw data. It's not that giant, but it's big enough. And then I go down to Calculate and press Enter. And there it is. 80.896 is the mean. And if you push down with your down arrow, you can see there's the min, there's the Q1, the median, Q3, and the max. They're all right there. These 5 numbers create the 5-number summary. All right, so I went and typed those in. Sorry, my computer ate my first video, so you'll have to bear with me here. So you can see the median is right here. You have half the scores below that value of 84. Then you have half the scores above that value. Because the data set was put in order, it's very obvious what the median is. It's 84, and that's what I wrote right here. Because the data set is in order, it's obvious that 84 is in the middle because it has 14 scores below it, these ones, and then 14 scores above it, those ones. The minimum is very obvious, it's 54. The max is 93. Of course, if your data set wasn't in order, the calculator would find it very quickly for you. Now the first quartile, if you look at this bottom half, what you want is the middle score, the number in the middle, the median, if you will, of that bottom half. Well, the median of the bottom half, it's 14 scores, so it's the middle between these two yellow ones, 75 and 77. So you add 75 plus 77 and divide by 2, and you'd have 76. Of course, you didn't have to do that because the calculator figured it out for you, but that's how you would calculate it by hand if you needed to, or if you needed to explain it to somebody. Similarly, on the top half right here, you can see that there's an even number of scores, so that 75th percentiles right here. It's the halfway spot between 88 and 89. So if you add 88 plus 89 and divide by 2, you get 88.5. So that's how to find all of those with the calculator and how to find them by hand, and then also how you could have figured out the median by hand if you so desired. So, matter of fact, I'm going to write just a little bit here. This is the average of, if you will, it's the median of 88 and 89. Okay, I can say average, it's fine. It's the mean, it's the median, it doesn't really matter, it's only 2 scores. This one, on the other hand, is the average of 75 and 77. All right, now, suppose that 80 is the 35th percentile, excuse me. All right, so that means that in symbols, P35 is equal to 80. Okay, that means that 35% of the students who took exam 3 in that Math 133 class scored below or equal to an 80% on the exam. So 35% scored below or equal to an 80, so 65% of the students scored above an 80, so 81 or higher. So let's put that in there as well. This implies 65% of the students scored higher than an 80. 80 itself counts in the 35th percentile by the definition up here. It says that K% of the observations are less than or equal to that value. So 35% are less than or equal to 80, so that means 65% are higher than 80, so 81 or higher. All right, next, let's look at the following ogive. So ogives we learned about in chapter 2. They're a percentile graph, a cumulative percentile graph. So we have here, President Obama was 47 when inaugurated. Approximately what percentile was he in? So what I did was I took this little blue arrow right here that's standing for President Obama, and I had it start off at 47. And then I drew straight up from 47 to hit the curve. Then I took my arrow and went straight horizontally left, or you could have gone right, but it would have been farther, over to the nearest axis, and I found that that was about where the 10 hits, so he's about the 10th percentile, or P10. All right, President Thomas Jefferson was in the 70th percentile for age, so he was an older president. By the way, notice that President Obama was a younger president, right? Young president. Because he's in only the 10th percentile. Right? So President Thomas Jefferson was an older president. He's in the 70th percentile, so he's more than half, right? Kind of above the 50th percentile, 50th being the median. So what I did was I started at 70 over here with this arrow, and I go straight horizontally to the curve. And then I take my pencil, arrow, whatever, and I draw straight down or straight up. It actually would work either way in this case. And I see how old he was. And it hits at about 55, 56, 57, some really close to that 58 mark. So I said he was about 58 years old. And he was an older president because he's in P70. Right? Being in this P70 means that he's older. Now, this seems all well and good.